Okay, so what an inverse relation is, okay, it maps the output values to input values. Okay, domains X and ranges Y switch. Okay, so basically just flip-flopping things. Okay. So, to verify inverses, you must show. Okay, so well, let's put it this way. You got f of x, that's going to be your original function. And to represent the inverse function, f to the negative first of x. It's not an exponent. That's how we represent inverse functions. Okay? F to the negative first of x, that's representing the inverse function. Now, to verify those inverses, what you're going to do is you are going to compose both of the functions. Okay? So f of the inverse, that should equal x, and then going the opposite way as well. Okay? So remember, inside function, that's you're going to end up plugging that into the inverse, and you're going to plug the inverse into the original function as well. Okay? You'll see that here in a minute. So, f of f inverse of x should equal x, and then the opposite should also equal x as well. Okay? That verifies that they are inverses. Okay, so let's actually just do a relation from a table here. So 0, 1, just plotting those points. 2, 3, 4, 5, 6, 7. Okay. Now, we said for an inverse relation, we flop the input and the output, right? Okay, so your x's become your y's become your x's. So, just flip-flopping that. Your y's become that 0, 2, 4, 6. And your y's become that 1, 3, 5, 7. And I plotted one of those wrong. 0, 1, 2, 3. Okay, so then plotting that inverse, you got 1, 0. Okay, 1, 0, 3, 2, 5, 4, and 7, 6. Okay, so you're just flip-flopping your x and y. Now, I'm going to draw the line y equals x. What do you notice with those points from the original relation compared to the inverse relation? So the blue points to the red points, what do you notice? Aren't they just reflected over that line? Okay, that's how inverse relations will always work. Okay, graphically, they'll always be reflected over that line. Okay. But the big thing to take from this one, flip-flop your input and your output. Flip-flop your x and y. Okay, that's how you're going to get an inverse relation. Okay, so graph the inverse, state the domain and range of each. Okay, so again, we're going to reflect it over that line of y equals x, correct? So, for this point, where would the inverse go? We reflect it over. We go there. Okay, so this point, that'll go there. let's just go this point, that'll go there. So that inverse, does that look like it's reflected over? Okay, so I just found those good points and I reflected those points over that y equals x. So, for parabola then, okay, that's just good. When you get a point on that line, it just stays on that line, right? So then when I go to this point, I don't like parabolas here. No, we're going to ignore the graphing part for now. I just want us to be able to find them. Okay, so to find inverses, your first step, swap x and y. Okay, so you're going to get a function, you're going to flip your x and y. Okay, second step, solve for y once you swap them. And then the third step, have your proper notation. Okay, so again, f inverse of x. That's your proper notation for an inverse function. Okay, so find an inverse of f of x equals negative 3x plus 6. F of x, we can just replace that with y, can't we? So y equals that negative 3x plus 6. What's the first step? It said swap x and y, correct? So literally flip-flop those. Nothing with the coefficients, literally just the x and the y. So then I'm going to have x equals negative 3y plus 6. Now, solving for y, okay, we have to subtract that 6 over. So we got x minus 6 equals negative 3y. And by dividing by that negative 3, so then we got x minus 6 over negative 3 equals y. And we should really reduce, okay? So when I divide that left side by that negative 3, I divide each of those terms by negative 3, correct? So it's even better, go to each term, divide that by negative 3. So then x over negative 3, that's negative 1/3 x. And negative 6 divided by negative 3, that's going to be plus 2, correct? And the last step is to have the proper notation, correct? So I got f inverse of x is equal to that negative 1/3 x plus 2. Okay. Flip-flop x and y, solve for y, have your proper notation. Second one, we got f of x again. Let's replace that with y. Okay, when I flip-flop x and y now, what's the next line of work that I got there? Hayden? Well, we gotta flip-flop x and y first, right? So what would I have? Jessica would be my next step so I got to solve for y, right? What would be the next step? Solve for y here. Minus 4, so x minus 4 equals 2y. Maria, next step? 2. Okay, and again, let's think, don't divide the whole thing by 2, just in case we can simplify. Do it to every single term. Okay, so x over 2, what is that? What's your coefficient if it's x over 2? Alex? 1/2. So I got 1/2 x. Negative 4 over 2, that's going to be minus 2 equals that y. Last step then. Morgan? Proper notation. Okay, that's telling me, okay, I don't have the original function anymore, I have the inverse function. Okay, and that's equal to that 1/2 x minus 2. Questions? Okay, verifying then. Okay, so I'm saying this is the original function, this is the inverse function, correct? So again, we said we have to compose both ways. Doing one way doesn't work. Okay, so we have to find f of f inverse of x, which is saying we're taking the inverse function and plugging it in to the original function, correct? So I'm replacing x with that. So negative 3, here's my x. So I'm going to replace it with that negative 1/3 x plus 2. And we got plus 6, correct? Now simplifying that, we got to distribute that negative 3. What's negative 3 times negative 1/3? Could be 1, right? So I got x, negative 3 times positive 2, that's going to give me minus 6 plus 6. That gets me to x. That's what we need to get to. If they are truly inverses, you have to compose them both ways and they got to get equal to x. So we're halfway there, right? We composed one way. Now, we're just going the opposite way. Now we're taking the original function, plugging that into the inverse. We got negative 1/3. Here's my x. So I have to replace that with the negative 3x plus 6. Plus 2. So again, we get that negative 1/3 times 3, so just x. Negative 1/3 times 6, so 6 divided by 3, right? Minus 2. Plus 2. So when we compose both ways, we got them equal to x, right? Which means they are inverses. Now, common mistake a lot of times that I see. Okay, I'll ask this on a test or quiz. I'll give you the original function, and people will just find the inverse function. Okay, that's not verifying. In order to verify, you have to compose them both ways. So don't just find the inverse again. I mean, that's going to tell you, yeah, they probably are inverses, meaning when I verify, I should get this. When I compose both ways, I get x. So make sure, if I ask you to verify, that is the process you have to do. Go ahead, give that one a try. Verify that those two are inverses of each other. Okay, first way we're gonna plug the inverse. Oh, we got to verify F of that. F and G, right? Okay, so it's basically determine are those inverses of each other. So in this case, I got to do F of G of X, correct? And I'm plugging the G of X into F of X. So 8 times that X to the 1/3 over 2, and we're taking that to the 3rd power, correct? It's replacing X with that function. Okay, then we got a quotient to a power, right? So we're going to take that power to both the numerator and denominator, correct? And multiply. So 8 times X to the 1/3 to the 3rd. 1/3 times 3 is 1, right? So 8 times X over 2 to the 3rd, which would be 8, which is 8x over 8, which simplifies to x. Okay. So we're good that way, right? Does one way work though? Okay. You have to do both. Okay. Because sometimes f of g of x will equal x, but then g of f of x will not equal x. Okay. You have to compose both ways. Then g of f of x, taking f of x, plugging that into g. Here's my x, which is 8x cubed. Taking that to the 1/3 power over 2. Simplify that numerator, right? 8 to the 1/3 power. Again, taking something to the 1/3 power is the same as cube rooting it, correct? What's the cube root of 8? 2. X to the 3rd to the 1/3. 3 times 1/3, we just get 1, right? Didn't do anything to the denominator. So 2x over 2 equals x. So since we compose both ways and they both equal x, they are inverses. Alright, I want to go back up to these now. Okay, so you guys notice the first step was always to flop x and y, right? Okay. So let's get some points here. This would be the original function. And we got negative 2, 2, negative 1, 0, negative 1, negative 1, 0, negative 2, 1, negative 1, and then 2, 2. Okay, so if I was to do the inverse now, we flop the input and output, right? So whatever I have in the x column, I'm going to put in the y. So negative 2, negative 1, 0, 1, 2. Okay. This y column is going to go into the x now. So 2, negative 1, negative 2, negative 1, 2. And we can plot those points from there, right? So 2, negative 2, negative 1, negative 1. Negative 2, 0, negative 1, 1, 2, 2. And that would be the inverse. Now, is the inverse a function? Or is it a relation? Okay, so remember, a function is you get one input equals one output, right? Okay, we had a test to verify that. You guys remember the vertical line test to determine if something's a function? If I draw a vertical line anywhere, Okay, it should only hit 1 point, right? I draw a vertical line, that's one input to one output. So since here, I hit 2 points, 1, 2, is that a function? No. Okay, it's a relation. So, whenever you find inverses, it's not always an inverse function, it's sometimes an inverse relation. This is a situation where when you find that inverse, it becomes an inverse relation because it does not pass that vertical line test. Okay, we started with the function. Okay, that's just a quadratic, right? Found the inverse. Okay, it's an inverse relation. Okay, because if we graph it, it does not pass that vertical line test, meaning it is not a function. All right. Go to the 7.4b as well. Go ahead and find the inverse of that function, negative 3x plus 6. Did we do that one already? Oh, we just verified. Okay, go ahead, find the inverse of that function. It's up pretty good. Okay, so f of x, that's just y, right? So y equals a negative 3x plus 6. Okay, Matt, what's the next step? Okay, what do I get when I flip x and y there? Okay, common mistake I will see is that. You're not flipping those terms, you're just flipping x and y, correct? The coefficient stays there. Okay. Mason, what's my next step? What's my next goal, I should say? Subtract the 6, because what's that going to help us do? Solve for y, right? Okay. Next step, Caitlin? Divide by negative 3. And just do it to each term, right? Because if things simplify, it's easier to see that way. And x over negative 3, what is that? Mara? Negative 1/3 x. Negative 6 over negative 3, that's going to be plus 2. Can I leave it? Am I done? Goal, what's the last thing I need to make sure of? What's that?
Put it into the final formula.
Yeah. Okay, we need I need to know that that's the inverse function, right? We found the inverse function. You need to tell me that it's the inverse function, so we need to have that notation that says this is the inverse. Okay? Go ahead, give that one a try. Okay, Drew, what's gonna help me? First step,
Write it out.
write it out. Instead of f of x, all right? Y equals, correct?
Yeah.
Aubrey, what's the next step?
Switch x and y.
Okay, when I flop x and y, what do I have?
X equals y to the first element.
Good. Solving, next step. Add 6. Spanner, what's the last step then? We gotta take the proper rud, correct? Fifth rud. So I got y is equal to the fifth rud of x plus 6. Last thing then. Megan,
Proper notation.
proper notation. Tell me that that's the inverse. Okay, go ahead, do that last one. Alright, so, got y equals, got 1/4 x squared, right? Flip flopping that x and y. Okay, so I saw some mistakes. How do I get rid of that 1/4? There's quite a few people here that made a mistake here. Okay, you divide by 1/4, right? Which is the same as multiplying by the reciprocal. 1/4 times what's going to get me 1? Morgan? 4, right? Then I got 4x equals that y squared. Square root now. Okay, and then I saw a lot of this. I liked it too. Square root of 4 is 2, right? Does the square root of x simplify though? No. Okay, so be careful. It should be 2 square root of x. That x will stay inside the radical still. Am I done? Need to have proper notation, right? Tell me that it's the actual inverse. So, f inverse of x is equal to that 2 square root of x. Alright. So, homework for this lesson. Okay, ignore the 7.4a book assignment, just do the 7.4b homework. Okay, just the worksheet. Okay, now one thing. Once you find the inverses of those, pick 3 of them to verify. Okay, find the inverse and then compose them both ways to make sure that they actually are inverses. Okay, you need to know how to do that, so make sure to practice it. Alright, you have 14 minutes. Let's use our time wisely and let's get to work. Aubrey, you want to hit the stop on that for me?